All right, we're going to go through the worksheet Balancing Chemical Equations, and feel free to stop this video at any point when you feel like you have enough information, like you have this down, you've got it mastered. And so we're going to go through kind of problem by problem. The first one, we're starting with oxygen, that's O2, and we're reacting it with iron, that's Fe, to make the compound iron oxide, that's FeO. And now, when I look at this, what I need to think about is how many of each atom do I have on both sides of this equation. So I look and I see O2, that means I have 2 atoms of oxygen. Over here I only have 1 atom of oxygen. So the oxygen itself is not balanced. And the way that we have to balance it is by using a coefficient. I write the number 2 in front of the compound FeO, and now I have 2 oxygens. I also have 2 iron, which means I have to come back and put a 2 in front of the Fe. Now, this one is a balanced equation. Let's look at the next one. We have aluminum hydroxide, that's AlOH3. That's the only reactant, so now we're going to products, is aluminum oxide, that's Al2O3, and H2O, water. And so we need to double check and make sure, do we have the same number of all of these atoms on both sides? So we have 3 different types of atoms. We've got aluminum atoms, we've got oxygen atoms, and we have hydrogen atoms. We need to make sure that they're all balanced. I see 1 aluminum atom. On the product side, I see 2 aluminum atoms. The aluminum is not balanced. I'm going to go ahead and put a coefficient of 2 in front of the aluminum hydroxide. And that changes this to 2 aluminum atoms. It also changes the number of oxygen and hydrogen. And here, I actually have a total of 6 oxygen now. When you see parentheses, it's like a grouping, and the number that's outside the parentheses multiplies everything that's inside of that grouping. So you actually have, in one molecule, you have 3 oxygen atoms. If you have 2 molecules, that means you have 6 oxygen atoms. You'd also have 6 hydrogen atoms. On my product side, in this I have 3 plus 1, so I have a total of 4 oxygen atoms. And then the hydrogen, I only have 2. So we've got to balance both those oxygen and hydrogen. And the way that we're going to do that is coefficients. If I put a multiplier on the water, coefficient of 3, now you actually have 6 hydrogen atoms. And that also changes the number of oxygen that you have to 6. And so now everything is balanced. 2 aluminum, 6 oxygen on both sides, and 6 hydrogen. You've got a balanced equation. We'll look at the next one. We have zinc plus H3PO4 makes zinc phosphate and hydrogen. Now I'm just copying these balanced or these unbalanced equations right off the worksheet. Now this one, I'm going to point out that you see this PO4 on both sides of the equation. That PO4 is a polyatomic ion known as phosphate. And you can actually balance the phosphate all as one group. And so when I do my kind of inventory of what do I have, I'm going to do it a little bit different. I've got zinc, I've got hydrogen, and instead of doing phosphorus and oxygen separate, since they're grouped on both sides of the equation, I'm going to leave them grouped on my little inventory. And so if I count, I got 1 zinc and 3 zinc. I know I'm going to have to put a coefficient over here. I have 3 hydrogen. Over here I have 2 hydrogen. Now, in this case, when you see 3 and 2, you can't just change one number without having to change the other. We need to find the common multiple of 3 and 2, which would be 6, of course. So if I make this into a coefficient of 3, then I would have 6 hydrogen. And I can also put a multiplier in front, so I have 6 hydrogen over there. For the phosphate, now notice that you have 2 of the phosphates, and over here you have 2 phosphates. So that's a balanced equation. The next couple I'm going to go through maybe a little bit faster. So I copied, that was the 4th one on the worksheet. This one, I noticed 2 iodide and 1 iodide, so I'm going to put a coefficient of 2. I see 2 chlorine and I see 2 chlorine, so I'm going to put a coefficient of 2. That one is balanced now. Go ahead and do the next one. I'm going to grab a new piece of paper here. So we've got KBr and then AlNO3, 3. And again, this is that group of atoms. This is a polyatomic ion nitrate, as its name. And so I can balance the nitrate kind of as a group. I don't need to think about necessarily the number of nitrogens individually and the number of oxygens individually. I can think of how many nitrates do I have. And so when I do this one, potassium is good. Bromine, I see 1 bromine and I see 3 bromine. So I'm going to have to balance that. Which also means I'm going to have to come back and fix the potassium. Sometimes you fix one and you have to go back and change the other one. So I need 3 potassium. And now actually this is a balanced equation because I have 1 aluminum, I have 3 nitrates on both sides, and so this is balanced. A couple more that we're going to do. Get my pencil. Backup pencil. Okay, where were we? Let's give this a try. Now this one, I see, I'm going to go ahead and do my inventory of what elements do I have. I have calcium, chlorine, and oxygen. Now notice this chlorine-oxygen compound over here, this polyatomic ion, it's split up, so I have to think of each atom in specific or individually on this one. So we see one calcium and one calcium. I see two chlorine and two chlorine. So far, so good. This one actually has 6 oxygen. Remember, this parentheses is like a grouping, and so you have to multiply everything inside that by whatever number is outside of that little grouping. And so 2 times 3 is 6 oxygen. Over here, there's 2 oxygen. And so to balance it, I just need a coefficient of 3, makes 6 oxygen. Oops. So we have Ki plus PbNO3 makes KNO3 and PbI2. And so once again, I see that nitrate on both sides, so I can balance that nitrate as a group. And so if I look, I see 2 iodine, so I'm going to put a coefficient of 2. I need to fix the nitrate, so I got to do a 2 there. And that should be a balanced equation. Let's do the next one. So we have Li2S, FeCl3 makes Fe2S3, and LiCl. And so I'm going to go ahead and start with the lithium. And notice I always do this in a pencil because sometimes you do have to erase coefficients that you write down, which I'm going to notice right away that I'm going to have to erase that coefficient of 2 because if I look at the sulfur, the S, I see 1 sulfur and I see 3 sulfur. And so I'm going to have to change that coefficient in front of the Li2S, which means I actually have, let's see, 6 lithium. So I need 6 lithium. And then 2 iron, 6 chlorine, 6 chlorine, balanced. A couple more to go. I think this is going to be a pretty easy one because I only got 2 different types of atoms. And so when I look at this, I see 1 mercury, Hg is mercury, so that's balanced. I see 2 oxygen, so I'm just going to balance this by putting a 2 in front of HgO, and then that balances with a 2 in front of Hg. Let's do this last one. So I have Ca plus AlCl3 makes CaCl2 plus Al. And so I need to look at the chlorine as what I'm going to have to balance. And here I see 3 chlorines on the reactant side, 2 chlorines on the product side. So I'm going to think about the common multiple. That common multiple is going to be 6. And so if I change the coefficient to make 6 chlorines, do the same thing over here, make 6 chlorines. So I multiply the AlCl3 by a coefficient of 2 and the CaCl2 by a coefficient of 3. Now I've got 6 chlorines, and I got to go back and fix the aluminum to make sure there's the same number of aluminum atoms and the calcium. And so now we've balanced it. All right, if you have more questions about balancing, make sure you ask. Take some practice, and good luck.